Assalamu alaikum. Welcome to lecture number 41 of the course on statistics and probability. Students, you will recall that in the last lecture I discussed with you interval estimation and hypothesis testing regarding mu1 minus mu2 based on the t statistic and the t distribution, and that situation was valid when the populations were normal, the standard deviations of the populations were unknown but equal, and the sample sizes were small. Towards the end of the last lecture, I began the discussion of the application of the t distribution in the case of paired observations. Let us continue that discussion and let us go back to the example that I quoted at the end of the last lecture. As you now see on the screen, 10 young recruits were put through a strenuous physical training program by the Army. Their weights were recorded before and after the training with the following results. For recruit number 1, the weight before the training was 125 pounds, whereas after the training it was 136 pounds. Similarly, we have the figures for all the other recruits. Using a level of significance of 5%, would you say that the program affects the average weight of the recruits? Assume the distribution of weights before and after the training to be approximately normal. Students, as I mentioned last time, this is a case of pairing, and we can say that this is natural pairing. कि वो जो रिक्रूट्स हैं, पहले आपने उनका वज़न पहले भी किया हुआ है और उसके बाद ट्रेनिंग के बाद आपने दोबारा से उनका वज़न किया, एंड वी आर इंटरेस्टेड इन फाइंडिंग आउट कि आया इस ट्रेनिंग की वजह से उनके वज़न पे कोई फ़र्क पड़ता है या नहीं पड़ता. As I was saying last time, students, the statistic in this particular case is t equal to d bar minus mu d over SD over square root of n. यानी बिल्कुल वही फॉर्मूला जो पहली मर्तबा म्यू की टेस्टिंग के वक्त था, सिवाय इसके कि अब हम x की बजाय d की बात कर रहे हैं. तो आइए इस पॉइंट को ज़रा तफसील के साथ कंसिडर करते हैं. सबसे पहली चीज़ है d. We are going to compute the differences in the weights before and after the training. So, as you now see on the screen, if we regard the weights after the training as x1, the weights before the training as x2, and we define d as x1 minus x2, then the 10 differences come out to be 136 minus 125 equal to 11, 201 minus 195 equal to 6, 158 minus 160 equal to minus 2, and so on. Students, ये जो 10 differences आए हैं, you should regard them as a sample of differences out of a population of differences. ये बड़ा इंटरेस्टिंग आइडिया मालूम होता है. देखिए, अगर हमारे पास 10 रिक्रूट्स ना होते, 10,000 होते, thousands and thousands of recruits होते, पूरी पॉपुलेशन होती, और थ्योरेटिकली हम ये कह सकते हैं कि अगर हमने उनमें से हर एक को इस फिजिकल ट्रेनिंग में से गुजारा होता, and we had recorded the weights before the training and after the training for all of them, then we could have found differences of this type for all of them, and that would be a large population of differences. These 10 differences can be regarded as a random sample out of that population. Students, another very, very important point to note is that if both x1 and x2 are normally distributed, then the difference d, which is x1 minus x2, that will also be normally distributed. This is because of a basic mathematical property of the normal distribution, and the property says that if x and y are normally distributed, then x plus y or x minus y will also be normally distributed. तो आप x, y कहें या x1, x2 कहें, पॉइंट ये है कि अगर वो दो वेरिएबल्स नॉर्मली डिस्ट्रीब्यूटेड होंगे तो उनका जो डिफरेंस है ना, दिस न्यू वेरिएबल इज ऑल्सो नॉर्मली डिस्ट्रीब्यूटेड. इन दिस प्रॉब्लम x1 इज द वेट आफ्टर द ट्रेनिंग, x2 इज द वेट बिफोर द ट्रेनिंग. तो वेट तो बहरहाल अप्रॉक्सीमेटली नॉर्मली डिस्ट्रीब्यूटेड होता ही है. Therefore, we can say that this population of differences x1 minus x2 is also normally distributed. ये बात बहुत important है, इसलिए कि अगर parent population normal हो, उसका standard deviation unknown हो और sample size small हो, तब ही तो हम T statistic apply करते हैं ना. तो यहाँ पे this is what is happening. We are assuming that we have a random sample of differences from a normally distributed population of differences. And of course, the standard deviation of the population, which I may call sigma d, is unknown. और जो हमारा sample size है, वो भी आपने देखा इस problem में, it is small, and we had only a sample of 10 recruits. So, all those assumptions and conditions are being fulfilled, and this is why in this particular case we will be applying the T statistic, which you now see on the screen. T is equal to d bar minus mu d over SD over square root of n. As I have said 2 or 3 times, this is similar to the statistic that we had earlier, which was T is equal to x bar minus mu over S over square root of n. ये जो statistic हमने पहले इस्तेमाल किया था, अगर मैं चाहती तो मैं इसको इस तरह से भी पढ़ सकती थी. T is equal to x bar minus mu x over Sx over square root of n. And if you replace x by d, then you get the one that we have now. Students, देखा आपने, पहला जो statistic था और अब जो है, actually they are one and the same. सिर्फ इतनी बात कि पहले हम x वेरिएबल की बात कर रहे थे और अब हमारा वेरिएबल d है. आपने देखा कि मैंने कहा कि आप Sx लिख सकते थे, mu x लिख सकते थे. There is nothing wrong with that. That is absolutely correct. क्योंकि उस वक्त जब हम x वेरिएबल के हवाले से सारी बातें कर रहे थे, तो हम mu और s जो कंप्यूट करते थे, हम उसके साथ ये सबस्क्रिप्ट x लगाते नहीं थे, लेकिन अगर हम लगाते तो it would have been all the more correct. After all, mu जो था, that was the mean of the population of the x values, and so there was nothing wrong with saying mu x. Similarly, Sx would have been the standard deviation, sample standard deviation of the x values that we had taken in the form of a sample from that population. तो बात फिर वही स्टूडेंट्स कि आप बेसिक पैटर्न को देखिए और देखिए कि वही बात रिपीट हो रही है जो पहले हो रही थी. All right, now that we have the statistic in mind, I think we should go to the 6 steps that we have in any hypothesis testing procedure, step by step, according to a methodical approach. The first step, of course, is the formulation of the null hypothesis and the alternative. And what is the null hypothesis in this particular example? Students, हम ये जानना चाहते थे ना कि ये जो फिजिकल ट्रेनिंग प्रोग्राम है, इसका वेट पे कोई असर पड़ता है या नहीं. तो नल क्या होगा? यही होना चाहिए ना, that there is no difference in the weight before the training and after the training. यानी उस प्रोग्राम से कोई फर्क नहीं पड़ता as far as the weight is concerned. And what will be the alternative? That it does make a difference. So the alternative says that mu1 is not equal to mu2. In this case, 1 is standing for the weight after the training, 2 is standing for the weight before the training, and what we are saying is कि वो बराबर नहीं है. इसका मतलब कि कुछ फर्क पड़ जाता है. हो सकता है कम हो जाता हो सकता है ज़्यादा हो जाता हो, फर्क पड़ रहा है. अब स्टूडेंट्स, इसी बात को हम इस तरह से भी तो कह सकते हैं ना कि नल हाइपोथेसिस ये है कि μ1 minus μ2 is equal to 0, and the alternative is that μ1 minus μ2 is not equal to 0. As you now see on the screen, μ1 minus μ2 is equal to expected value of x1 minus expected value of x2, इसलिए कि expected value का मतलब ही mean होता है. And this can be written as expected value of x1 minus x2, इसलिए कि ये तो basic algebraic equation है that e of x minus y is equal to e of x minus e of y. So μ1 minus μ2 equal to 0 means expected value of x1 minus x2 equal to 0, or in other words, expected value of d equal to 0, or in other words, mu d equal to 0. And students, this is exactly our null hypothesis in terms of the variable d. H naught mu d is equal to 0, and H1 mu d is not equal to 0. The next step is the level of significance, and as you now see on the screen, in this problem we set it to be the usual level, 0.05. The test statistic under H naught, as mentioned earlier, is t is equal to d bar minus mu d over st over square root of n. But since our null hypothesis says that mu d is equal to 0, therefore t can be written as simply d bar over st over square root of n. Now, it can be mathematically proved that this particular statistic follows the t distribution with n minus 1 degrees of freedom, exactly similar to what we had when we were considering the variable x and testing for the mean of that variable. The fourth step is the computation of the statistic, and as you now see on the slide, in order to find t, we first have to find SD, and to find SD, we need to have a column of d square, which you see in the last column of the table that you have in front of you now. The d square values are 121, 36, 4, 169, and so on. Substituting the sum of this column and the sum of the earlier column in the formula of SD square, we obtain SD square equal to 50.23, so that SD comes out to be 7.09. Of course, d bar is very easily found by simply dividing the sum of the d column 47 by 10, and that comes out to be 4.7. Hence, the computed value of our test statistic in this problem comes out to be 2.09. Students, obviously, we would like to compare this value with the critical value. And what is the situation now? Is it a one-tailed or a two-tailed test? Of course, it is a two-tailed test, इसलिए कि हमारा alternative hypothesis ये था that mu d is not equal to 0. Either mu d is less than 0 or mu d is greater than 0. और चूंकि less और greater दोनों sign involve हो गए, इसलिए both the tails of our t distribution are involved, and therefore we will have to divide our level of significance 5% by 2, half of it in the left tail, half in the right. So we will have 2.5% area to the right of the critical value that we will have on the right tail, and 2.5% area to the left of the critical value that we will have on the left tail. Now, how do we find the critical value? Degrees of freedom n minus 1 है. हमारे पास 10 recruits थे, तो 10 minus 1 means 9, and so when we look in the T table against 9 degrees of freedom under 0.025, what do we get? As you now see on the slide, the critical values come out to be 2.262 and minus 2.262. अच्छा, यहाँ पे एक इंटरेस्टिंग पॉइंट है. देखिए, आप कहेंगे कि ठीक है 10 रिक्रूट्स थे, लेकिन अगर हम अलग अलग देखें तो 10 वैल्यूज हैं वेट बिफोर द ट्रेनिंग की, 10 वैल्यूज हैं वेट आफ्टर द ट्रेनिंग की. तो अगर हम उस हिसाब से चलें जिस तरह हम लास्ट टाइम चल रहे थे, तो इन ऑर्डर टू टेस्ट μ1 इक्वल टू μ2, तो आपको याद है कि डिग्रीज ऑफ फ्रीडम उस वक्त थी n1 प्लस n2 माइनस 2. तो उस हिसाब से शायद आप कहें कि हमें करना चाहिए 10 प्लस 10 माइनस 2, 10 बिफोर द ट्रेनिंग, 10 आफ्टर द ट्रेनिंग वैल्यूज, तो हो गई 20, 20 minus 2, 18. Why did I not use 18 degrees of freedom, students? The reason is, as I explained earlier, अब आप इसको एक population of D's यानी differences तस्वुर करें और ये समझें कि इस population में से you have drawn one sample of size 10 in this case, a sample of D's. ये दो अलग अलग सैंपल जिसके लिए हम कहें कि n1 प्लस n2 माइनस 2, ये उस तरह की सिचुएशन नहीं है. दिस इज द केस ऑफ पेयर्ड ऑब्जर्वेशंस, जहां पे हम इसको इस दूसरे तरीके से ट्रीट करते हैं, जैसा कि मैं आपके साथ बात कर रही हूं. ऑलराइट, व्हाट इज द लास्ट स्टेप? द कंक्लूजन. Our computed value of T came out to be 2.09 and the critical values are plus minus 2.262. इसलिए साफ जाहिर है कि हमारी वैल्यू एक्सेप्टेंस रीजन के अंदर फॉल कर रही है and therefore we can accept H0. इसका मतलब ये हुआ that this data does not provide evidence to conclude that this particular physical training program affects the weights of those recruits. Of course, we are not talking about any particular individual, but we are talking on the average. Let us consider one more example on paired observations. As you now see on the slide, the following data give paired yields of two varieties of wheat. Each pair was planted in a different locality. The values are that for locality number 1, the yield for variety 1 is 45, whereas the yield for variety 2 is 47. Similarly, for locality number 2, the yield of variety 1 is 32 and the yield of variety 2 is 34. इसी तरह से हमारे पास बाकी figures मौजूद हैं. Now, we would like to test the hypothesis that on the average, the yield of variety 1 is less than the yield of variety 2. Also, in this problem, we are required to state the assumptions that are necessary to carry out the test that we are going to carry out. In addition, there is a very interesting question. How can the experimenter make a type 1 error? And what are the consequences of his doing so? Next, इसी तरह से हम ये भी जानना चाहते हैं कि how can the experimenter make a type 2 error and what are the consequences of his doing so? In addition, we would like to compute the 90% confidence interval for the difference in the mean yield of the two varieties. Students, सबसे पहले आप ये नोट करें that this is again a case of paired observations. हमारे पास 10 मुख्तलिफ फार्म्स हैं और हर फार्म में हमने आधे में वैरायटी 1 को बोया है और आधे में वैरायटी 2 को। इसलिए सॉइल इज कॉमन, और अब अगर पैदावार में कोई फर्क आ रहा है तो इट इज नॉट बिकॉज ऑफ सॉइल और एनी अदर एक्सट्रेनियस फैक्टर्स which could affect the yield. It is simply the difference in the varieties that is producing the difference in the yield, and this is exactly what we are wanting to measure. So, if we are satisfied that this is the way we should treat this problem, then what are the assumptions in order to conduct the test? As you now see on the screen, we will be assuming that the differences in the yields of the two varieties in the 10 farms that we have, these are a random sample from the population of differences, and the population of differences is normally distributed. इसका यही मतलब हुआ कि हम सोच सकते हैं कि अगर हम 10 की बजाय 100, 1000, 10,000 फार्म्स की बात करें, हर फार्म में आधे में वैरायटी 1, आधे में वैरायटी 2 को हम बो दें, तो हमारे पास एक पॉपुलेशन ऑफ यील्ड्स फॉर वैरायटी 1 एज वेल एज फॉर वैरायटी 2 हमारे पास ये आ जाएगी। और उसके बाद अगर हम डिफरेंसेस कंप्यूट कर लें, देन वी हैव अ पॉपुलेशन ऑफ डिफरेंसेस। इस पॉपुलेशन में से वी आर ड्रॉइंग अ रैंडम सैंपल ऑफ साइज 10। ऑलराइट स्टूडेंट्स, व्हाट इज इट दैट वी आर वांटिंग टू टेस्ट? स्टेटमेंट ये थी कि वैरायटी 1 की यील्ड जो है ऑन द एवरेज इट इज लेस देन वैरायटी 2, ये हम टेस्ट करना चाहते हैं। देखिए, इसके अंदर लेस देन का साइन है, इक्वल का साइन इसमें नहीं आता। इसका मतलब है कि दिस विल बी इन दी ऑल्टरनेटिव हिपोथेसिस। अगर हम वैरायटी 1 के लिए सबस्क्रिप्ट 1 यूज करें और वैरायटी 2 के लिए सबस्क्रिप्ट 2, देन व्हाट आर वी सेइंग? We are saying mu1 is less than mu2. This comes in the alternative hypothesis. And what is the null hypothesis then? Mu1 is greater than or equal to mu2. लेकिन अगर हम इन hypotheses को translate करें into those which are in terms of D, then as you now see on the screen, the null hypothesis is mu D is greater than or equal to 0. And the alternative, mu D is less than 0. The second step is the level of significance, and let us keep it as 0.05, the usual level that we take. The third step is the test statistic. T is equal to D bar minus mu D over SD over square root of n. And the fourth step is to compute this statistic. Carrying out the computations just as in the last example, our D bar comes out to be minus 2.8, SD square is equal to 1.7333, so that T comes out to be minus 6.71. Now, the critical region lies on the left tail of the distribution, and looking under 0.05, in the T table against 9 degrees of freedom, the value is 1.833, but because we have the left tail in our mind, therefore we say that the critical value is minus 1.833. The last step, of course, is the conclusion. Our value is minus 6.71, which is far out in the left tail, and therefore we reject the null hypothesis. And therefore we conclude that there is sufficient evidence for us to say that mu1 is less than mu2. यानी variety 1 की yield जो है on the average, it is less than the yield of variety 2. Students, you will recall that there was a very interesting question in this problem. How can the experimenter make a type 1 error, and what will be the consequences of his doing so? आपको याद है ना, टाइप 1 एरर का मतलब है that H0 is actually true, but you reject it. इस प्रॉब्लम में H0 क्या था? mu1 is greater than or equal to mu2. यानी mu1, the mean yield of the first variety, is either more than or at least equal to the yield of variety 2. तो अगर ये सच हो और हम इसे रिजेक्ट कर दें और हम कहें कि वैरायटी 1 की यील्ड कम है वैरायटी 2 से, तो इस ऐसा एरर करने के कॉन्सिक्वेंसेस क्या होंगे? स्टूडेंट्स, फर्ज कीजिए कि वैरायटी 1 जो है दैट इज लेस एक्सपेंसिव देन वैरायटी 2, और हम कहें कि जी एक्सपेंसिव तो कम है लेकिन उसकी यील्ड भी कम है, लिहाजा वी शुड नॉट take that one, we should be buying the other one and sowing the other one. But then students, will we not be wasting money? इसलिए कि दरअसल तो उसकी yield less नहीं है, असल में तो H0 is true, और अगर वो inexpensive है तो फिर तो हमें वही लेनी चाहिए थी ना। आपको मैं encourage करूंगी कि इस मामले पे गौर कीजिए. This is how you link the mathematical theory with real life, and if you pay attention to it, it can be very interesting. The other question was, how can the experimenter make a type 2 error? Type 2 error क्या होता है कि जो null hypothesis है that is actually false, but you accept it because of your data being that way. तो इस प्रॉब्लम में null hypothesis ये है कि μ1 is greater than or equal to μ2. फर्ज कीजिए कि ये असल में गलत है, असल में μ1 is less than μ2. वैरायटी 1 की यील्ड कम है वैरायटी 2 से ऑन द एवरेज, लेकिन हम अगर एक्सेप्ट कर लें H0 को विच इज एक्चुअली फॉल्स, तो हम कहेंगे कि नहीं जी वैरायटी 1 की यील्ड कम नहीं है वैरायटी 2 से. तो ऐसा करने से नुकसान क्या होगा? ऐसा करने से नुकसान ये होगा स्टूडेंट्स कि हम जो इजाफा कर सकते थे पैदावार में बाय यूजिंग वैरायटी 2 वो हम नहीं कर सकेंगे बिकॉज ऑफ दिस एरर दैट वी हैव कमिटेड. सो दिस इज द काइंड ऑफ सिचुएशन दैट वी डील विद इन hypothesis testing. Now the last part of the question was construct a confidence interval for μ1 minus μ2. And how do we proceed with this problem? आपको याद है ना कि ये वाला प्रॉब्लम तो पेयर्ड ऑब्जर्वेशंस का है, तो इसका मतलब ये हुआ कि जो हमारा कॉन्फिडेंस इंटरवल है दैट ऑल्सो हैज टू बी इन दैट मैनर एज यू नाउ सी ऑन द स्क्रीन. इन द केस ऑफ पेयर्ड ऑब्जर्वेशंस द कॉन्फिडेंस इंटरवल फॉर μ1 minus μ2, in other words the confidence interval for mu d is given by d bar plus minus t alpha by 2 n minus 1 degrees of freedom multiplied by s d over square root of n. Once again, note कीजिए exactly the same formula that we had in the first instance when we were trying to construct a confidence interval for mu, the mean of our x variable. उस वक्त फॉर्मूला क्या था? x bar plus minus t alpha by 2 n minus 1 degrees of freedom into s over square root of n. और ये फॉर्मूला बिल्कुल वैसा ही है, the only difference being that our variable now is not x but d. So let us apply this in this problem. As you now see on the screen, d bar is equal to minus 2.8, sd is 1.32 and n is equal to 10, and therefore our confidence interval is minus 2.8 plus minus t alpha by 2 at 9 degrees of freedom into 1.32 over square root of 10. As noticed earlier, the value of t alpha by 2, that is t 0.025 at 9 degrees of freedom. अब ये जो t alpha by 2 की बात हो रही है, स्टूडेंट्स नोट कीजिए कि हम चाहते हैं कि हम 90% कॉन्फिडेंस इंटरवल निकालें. इसका मतलब ये हुआ that 90% area in the middle, 5% to the left, 5% to the right. So having a look at the area table of the t distribution, of course the t-value comes out to be 1.833, just as in the case of hypothesis testing that we did a short while ago. Therefore, putting the value 1.833 in the formula, our confidence interval comes out to be minus 3.565 to minus 2.035. And rounding these figures, the 90% confidence interval for mu1 minus mu2 is minus 3.6 to minus 2.0. As you can see, the values are negative, and this means that mu1 is less than mu2. जाहिर है अगर mu1 mu2 से कम होगा तब ही mu1 minus mu2 negative आएगा ना. All right, students, we have conducted a number of tests and constructed a number of confidence intervals based on the t distribution. हमने mu की बात की, mu1 और mu2 की बात की, paired differences की बात की. इससे पहले you will recall that we were testing about mu on the basis of the Z statistic, and also when we were doing the Z statistic, we were testing about P1, P2, and also constructing confidence intervals regarding proportions. Another very important quantity that we might wish to estimate is the variance or the standard deviation of our population. अगर हम sigma square या sigma के बारे में statistical inference करना चाहें, then what will be the procedure? Students, you will be interested to know that there is another distribution called the chi-square distribution, and this is the one that will enable us to do statistical inference for sigma square, the variance of the population. So, before I do the application of the chi-square distribution in real life situations, let me first define this distribution for you in a formal manner. As you now see on the slide, the mathematical equation of the chi-square distribution is f of x is equal to 1 over 2 raised to nu by 2 into the gamma function, gamma of nu by 2, and this whole quantity multiplied by x raised to nu by 2 minus 1 multiplied by e raised to minus x by 2, and this whole equation is valid for x lying between 0 and infinity. जी हाँ, आप फिर से वही बात कह रहे हैं ना, that it's a very complicated equation. All I would like you to do is to note that it has only one parameter represented by nu, and also note that x ranges from 0 to infinity, और इसकी जो properties हैं वो हम इसके बाद discuss करते हैं one by one. Let us have a look at the equation one more time. F of x is equal to 1 over 2 raised to nu by 2 gamma of nu by 2 x raised to nu by 2 minus 1 e raised to minus x by 2. आप देख रहे हैं कि सिर्फ nu ही वो quantity है which is the unknown quantity and which is the one lone parameter of the chi-square distribution. Now, coming to the properties of the chi-square distribution, first and foremost, we can say that it is a continuous distribution ranging from 0 to infinity, as is evident from its equation. And as far as the shape of the distribution is concerned, the parameter nu determines the shape. Nu is known as the degrees of freedom of the chi-square distribution, and there is a different chi-square distribution for each number of degrees of freedom. As such, it is a whole family of distributions, just as we had in the case of the t distribution or the normal distribution or for any other distribution. The curve of the chi-square distribution is positively skewed, but the skewness decreases as nu increases. Students, ये जो point अभी मैंने आपको दिया, इसका मतलब ये हुआ कि जैसे जैसे आप degrees of freedom बढ़ाते चले जाते हैं, उसकी जो skewness है, that becomes less and it looks more and more like a normal distribution. The next property, as you now see on the slide, the diagram that you have in front of you now, in this we have drawn 3 chi-square distributions, one for 2 degrees of freedom, one having 6 degrees of freedom, and one having 10 degrees of freedom. And you can see that whereas the chi-square distribution with 2 degrees of freedom is extremely skewed, the one having 10 degrees of freedom is much less skewed and looks much more like a normal distribution. The next property pertains to the mean of the chi-square distribution, and it has been mathematically proved that the mean of the chi-square distribution is equal to nu, the number of degrees of freedom. As far as its variance is concerned, it is equal to 2 times nu. इसका मतलब ये हुआ कि अगर हम 10 degrees of freedom वाली chi-square distribution की बात कर रहे हैं, तो उसकी जो mean value है, that is equal to 10, और उसका जो variance है, that is equal to 2 times 10, that is 20. यानी अगर हम इसका square root लें, square root of 20, how much is that? Is it 4 point something? Yes. Then the standard deviation, the spread of this distribution is square root of 20. The next property is also very interesting. As you now see on the slide, the moments about the origin for the chi-square distribution are as follows. Mu1 dash is equal to nu. Mu1 dash, of course, is the same thing as the mean, because after all, do you not remember that the first moment about the origin, in other words, the first moment about 0, is exactly the same thing as the mean. Also, mu2 dash is equal to nu into nu plus 2, mu3 dash is equal to nu into nu plus 2 into nu plus 4, and mu4 dash is equal to nu into nu plus 2 into nu plus 4 into nu plus 6. देखा आपने किस कदर खूबसूरत फॉर्मूला है. It just goes on in a systematic pattern. But students, we are more interested in the moment ratios, and as you now see on the slide, the first moment ratio, beta 1, comes out to be 8 over nu, and the second one, beta 2, comes out to be 3 plus 12 over nu. Students, आपको याद है अभी थोड़ी देर पहले मैंने आपसे कहा that as the degrees of freedom increase, the skewness of the chi-square distribution decreases and it becomes more and more like the normal distribution. इस बात को इन मोमेंट रेशियोज के साथ रिलेट कीजिए जो अभी अभी आपके सामने प्रेजेंट किए गए. Since beta 1 is equal to 8 over nu, isn't it obvious that if nu tends to infinity, beta 1 will tend to 0? And also, since beta 2 is equal to 3 plus 12 over nu, as nu tends to infinity, beta 2 will tend to 3 plus 0, and that is 3. And students, do you not remember that for the normal distribution, beta 1 is equal to 0 and beta 2 is equal to 3. Hence, what we said earlier regarding the shape of the chi-square distribution is validated by the moment ratios. Students, having discussed the basic properties of the chi-square distribution, let us now begin the discussion of its role in estimation and hypothesis testing. As I said earlier, we can do hypothesis testing or estimation regarding the variance of our population on the basis of the chi-square distribution. Let me explain this point with the help of an example. Suppose that an aptitude test has been devised in such a way that it carries a total of 20 marks, and suppose that this test is administered on a large population of students, and when the result comes out, we find that the marks of the students are normally distributed. Now, a random sample of size 8 is drawn from this normal population, and the sample values are 9, 14, 10, 12, and so on. We are required to find the 90% confidence interval for the population variance sigma square, representing the variability in the marks of the students. Students, आपने नोट किया कि इस वक्त हम म्यू में नहीं बल्कि सिग्मा स्क्वायर में इंटरेस्टेड हैं, द वेरिएशन इन द मार्क्स ऑफ द स्टूडेंट्स. यानी हम देखना चाहते हैं कि उनके जो IQs हैं क्या वो बहुत ज़्यादा वेरी करते हैं या थोड़ा वेरी करते हैं. Let us have a look at the data once again. The marks of the students in our sample are 9, 14, 10, 12, 7, 13, 11 and 12. आप देख रहे हैं that these marks are not all the same. Obviously, there is some variation. अब अगर हम subjectively बात करें, हम में से कुछ लोग कहेंगे कि इनमें ज़्यादा variation नहीं है. Some will say that there is quite a bit of variation. So, obviously, we need a proper mathematical way of doing it. And as you now see on the screen, if we are interested in constructing a 90% confidence interval for sigma square, it is given by summation x minus x bar whole square over chi square 0.05 at nu minus 1 summation x minus x bar whole square over chi square 0.05 n minus 1 degrees of freedom. This is the lower limit, and the upper limit is summation x minus x bar whole square over chi square 0.95 n minus 1 degrees of freedom. The next slide shows what we mean by chi square 0.05 and chi square 0.95. The value chi square 0.95 indicates that value on the x-axis, the area to the right of which is 95% of the total area under the chi-square distribution. Similarly, the value chi square 0.05 is that point on the x-axis, the area to the right of which is 5% of the total area. As indicated already, the degrees of freedom that we have to use are n minus 1, and in this problem that is 8 minus 1 and that is 7. Now, in order to find the values of chi square, we will need to consult the chi square table, which you now see on the screen. The very first column indicates the degrees of freedom, and the very top row indicates the areas that we would like to have to the right of our chi square values. Hence, in this particular problem, if we want 90% confidence, then we will be looking against 7 degrees of freedom. Once we will be looking under 0.95 and we find the value to be 2.17, and the other time we will be looking under 0.05 so that we find that chi square is equal to 14.07. Substituting these values in the lower and upper limits, we obtain summation x minus x bar whole square over 14.07 as the lower limit and summation x minus x bar whole square over 2.17 as the upper limit. अब सवाल ये पैदा होता है कि summation x minus x bar whole square की value क्या है? That is very obvious. We have the data and we can find these values either directly or by the shortcut formula. So, as you now see on the slide, in this problem, x bar is equal to 88 over 8 because the sum of the values is 88 and therefore x bar is equal to 11, and substituting this in the formula sum x minus x bar whole square, we obtain 9 minus 11 whole square plus 14 minus 11 whole square plus so on, so that the sum of the squares of the deviations of the values from their mean comes out to be 36. Substituting this number 36 in the lower and upper limits, we obtain 2.56 as the lower limit and 16.61 as the upper limit of our 90% confidence interval for sigma square. Students, we have found the 90% confidence interval for sigma square. The values are lower limit 2.56 and upper limit 16.61. Now, this seems to be a bit wide, right? But इस पे गौर करें कि अगर हम सिग्मा स्क्वायर की बजाय सिग्मा की बात करें, यानी स्टैंडर्ड डिविएशन की, तो क्या हमें ऐसा करना चाहिए कि जो लिमिट्स हमने अभी वेरिएंस के लिए निकाली हैं उनका स्क्वायर रूट ले लें and that will give us the confidence interval for sigma. As you now see on the slide, if we do so, then the lower limit for sigma comes out to be 1.6 and the upper limit 4.1. And you can see that this, of course, is much narrower than what we had for the variance. But then do keep in mind that after all, the variance was in square units, whereas the standard deviation itself is in the original unit. इस तरह का तरीका हम अडॉप्ट कर लिया करते हैं कई दफ़ा कि बुनियादी फार्मूला तो सिग्मा स्क्वायर के लिए है, but later we may take the square root and we can then regard it as a confidence interval for sigma. Students, सारा प्रॉब्लम तो हल हो गया, हमने सॉल्व कर लिया, लेकिन सवाल ये है कि how did we achieve this particular formula? Well, it has a derivation similar to the derivation that I conveyed to you for the confidence interval for mu based on the Z statistic. But I will not be doing the detailed derivation of this particular formula in this course. All I would like you to note is that the basic requirement for this formula to be valid is that the population from which the sample is drawn, that population should be normally distributed. All right, having done interval estimation regarding sigma square, let us now proceed to hypothesis testing regarding the variance of the population. Let me explain this with the help of an example. As you now see on the slide, the variability in the tensile strength of a type of steel wire must be controlled carefully. A sample of the wire is subjected to test and it is found that the sample variance is 31.5. The sample size was n equal to 16 observations. Test the hypothesis that the population variance is 25 against the alternative that the variance is greater than 25. Use a 5% level of significance. Students, आप agree करेंगे कि किसी भी production process में हम चाहते हैं कि जो specifications हैं product उसके मुताबिक हो, और variability जो है ना, that is what we want to control, and that is exactly what we have in this particular problem. So we want that the variability should not be greater than 25 in terms of the variance of the tensile strength. Now, how do we solve this problem? As you see on the slide, the null hypothesis is that sigma square is equal to 25, whereas the alternative is that sigma square is greater than 25. The level of significance is 5%, and students, the test statistic in this particular situation is summation x minus x bar whole square over sigma square, which under H naught has a chi-square distribution with n minus 1 degrees of freedom, assuming that the population is normal. In order to calculate the value of chi-square, we note that summation x minus x bar whole square is equal to n times s square, and substituting these values in the formula and substituting 25 instead of sigma square, we obtain chi-square is equal to 20.16. The next step is the critical region, and since this is a right tail test, students, therefore we will look against 16 minus 1, that is 15 degrees of freedom under 0.05, and doing so we obtain the critical value as 25.00. Since our computed value 20.16 is less than 25, therefore we accept the null hypothesis, and we do not find evidence to conclude that the variability in the tensile strength is greater than 25. Students, in today's lecture, we discussed the difference between means in the case of paired observations, and after that, we began the discussion of the chi-square distribution. I would like to encourage you to study these concepts in detail, and until next time, Allah Hafiz.